Hello and welcome back. This is lesson 1, parabolic flight or zero-G flight. So the first question we have to ask is, can we change gravity? And the answer is no. Gravity is a force that a mass exerts on other masses around it, and it depends on the mass of the object. So everything actually exerts gravity on the objects around it. Even you do. You're just so small that the amount of gravity that you exert on the objects around you is not even measurable. It's so tiny. But the bigger an object is, the more mass it has, the more gravity it's going to exert on the objects around it. That's why we feel different amounts of gravity on Earth compared to other planets. Like the moon, for instance, is smaller than Earth, so we experience less gravity on the moon than we do on Earth. So okay, we can't change gravity, but we can change how we experience gravity. And the way that we do this is using reactionary forces and inertia. So think about a roller coaster. At the top of the roller coaster, your body, because of inertia, wants to keep going upwards. So when the roller coaster changes its direction, we actually get a sense that we're floating. We feel like we're not experiencing any gravity because our bodies want to go up and the roller coaster is going down. So we kind of get that balance in between where we get no gravity. So we can also do this with something like gravitron that you might have at the fair. So we use centrifugal force where our bodies want to be pushed outwards and the machine keeps spinning around. And so we feel like we're being pressed against the outer wall. So we're experiencing hypergravity. So we can change how we experience gravity. So let's go back to thinking about those roller coasters. First of all, why would we call this parabolic flight? It's because it follows a flight path very much like the roller coaster that's in the shape of a parabola. So if you were to take off your seatbelt when you were sitting in that roller coaster, you would actually float off the seat and you would get that microgravity experience for a little bit. And that's what we're taking advantage of here in the parabolic flight. We're using this shape to allow us to experience microgravity. So when our airplane flies in this parabolic shape, when we get to the top of that shape and we kind of float out of our seats, or in this type of flight where there are no seats, we float off of the bottom of the airplane and we get that microgravity or free falling experience. Technically, we're falling. It's just that the airplane is falling a little bit faster than us and doesn't catch us. So we feel like we're floating. Now, if you were to change the shape of that parabola and make it a little bit wider, now your body is falling at a rate that's just a little bit slower than the airplane as it's changing direction. So that means we feel like we're lightly touching the bottom floor of the airplane, and we feel like we're in light gravity, maybe like lunar gravity. Now, on either side of that parabola, when the airplane is climbing or coming back down, it is actually going up or down faster than our bodies are. And so we're being pressed against the floor of the aircraft. And this is where we feel hypergravity. So you feel really, really heavy. So we can get different amounts of gravity that we experience by changing the angle that the plane catches us at. And here's what an actual parabolic flight looks like. So first, we're in normal gravity where the plane is just going along straight. So this is what we call 1G or 1 Earth gravity. As we climb, then we're pushed against the floor of the fuselage or the tube of the aircraft, and we experience that hypergravity. So almost twice the amount of gravity you would experience on Earth. At the top of the parabola, we float, or we get that lighter amount of gravity depending on the shape of our parabola. So we can get zero gravity, lunar gravity, which is about 1/6 G, or Martian gravity, which is about 1/3 G. Then back down we go, back into that hypergravity stage, and then we flatten out into normal gravity again. And we can do this over and over again. And each time at the top of the parabola, we get 20 to 30 seconds where we experience that different type of lightness. So the different types of microgravity or lunar or Martian gravity. So just a quick thing to think about at the end here. Why is skydiving different? So when you jump out of an airplane, why don't you get that same sense that you're just floating? And this is because there are different forces that are acting on you when you jump out of the airplane. When you're inside the airplane, the tube or the fuselage is stopping the air around you from pushing up. So you don't actually feel the exertion of the forces from the air. When you jump out of the airplane, however, the air around you is stationary and you're pushing down against it. So not only do you have gravity pulling you down, but you have the friction from the air keeping you up. So if you change your shape from, say, this boxy big shape that has a lot of friction acting on it into a pointy triangular shape pointing downwards, you can change your speed because you have less air friction working on you if you're in that pointy shape, but the amount of gravity pulling you down is the same. So the resulting force, or when you add those together, is more towards the gravity pulling you down faster. Just something to think about before we get into the actual science of how gravity works.